Welcome back to our channel, where we explore fascinating aspects of the science world. Today, we have a thought-provoking topic that will make you rethink traffic congestion. Have you ever wondered that, why do mirrors reverse left and right, not up and down? Please watch the video until the conclusion, and then like and share it with your friends. Your subscription can motivate me to create more informative videos for you. So, let's get started. Mirrors have long fascinated us with their ability to reflect our surroundings and show us our own reflections. However, if you've ever looked closely at your reflection in a mirror, you may have noticed something peculiar. The left and right sides appear to be reversed. But why is it that mirrors reverse left and right, and not up and down? In this video, we will explore the science behind this phenomenon and unravel the mysteries of mirror reflections. Mirrors have been used for various purposes throughout history, from personal grooming to scientific experiments. They play a significant role in our daily lives, but have you ever wondered why the reflection in a mirror appears reversed? The answer lies in the way mirrors interact with light and how our brains interpret the visual information received. Number 1. Understanding mirror reflections. When light hits a mirror, it undergoes a process called reflection, where it bounces off the mirror's surface and travels back to our eyes. The mirror reflects light in a way that preserves the angles at which the light rays hit its surface. This preservation of angles is what allows us to see a clear and accurate reflection of objects in the mirror. Number 2. The perception of reversal. The perception of left-right reversal in mirrors is not actually a physical phenomenon but rather a result of our brain's interpretation of the reflected image. Our brains are wired to process visual information in a way that aligns with our experiences and expectations. Thus, when we see our reflection in a mirror, our brain interprets it as if we are facing the mirror directly. Number 3. Mirrors and spatial orientation. The concept of left and right is inherently linked to our spatial orientation in the world. Our brains have evolved to understand and navigate our surroundings based on this orientation. When we see ourselves in a mirror, our brain automatically applies the same left-right orientation, leading to the perception of reversal. Number 4. The physics of mirror reflections. From a physics standpoint, mirrors do not actually reverse left and right. Instead, they reverse the front-back orientation of objects. If you were to place an object in front of a mirror, the mirror reflection would appear as if the object has turned around and is facing away from you. This reversal of the front-back orientation creates the illusion of left-right reversal. Number 5. The illusion of left-right reversal. To better understand the illusion of left-right reversal, consider this example. If you raise your right hand in front of a mirror, your reflection appears to raise its left hand. However, if you turn around and face away from the mirror, your right hand will still be on the right side. The mirror's reflection is simply a flipped version of the front-back orientation, leading to the perception of left-right reversal. Number 6. Experiments with mirrors. Various experiments have been conducted to explore the phenomenon of mirror reflections. One experiment involves placing an object with text in front of a mirror. The text appears reversed in the mirror because it is the back side of the text that is facing us. This experiment demonstrates how mirror reflections can create the illusion of text reversal. Number 7. The role of light. Light plays a crucial role in the perception of mirror reflections. The way light interacts with objects and reflects off a mirror's surface determines the image we see. Without light, mirrors would not be able to reflect anything, and we would not observe the intriguing phenomenon of left-right reversal. Number 8. Mirror reversal in everyday life. The concept of left-right reversal in mirrors has become so ingrained in our daily lives that we hardly notice it. We have adapted to this reversal and effortlessly adjust our movements and actions accordingly. For example, when driving a car, we instinctively know how to interpret the side mirrors to navigate safely. Number 9. The concept of front-back reversal. Understanding the concept of front-back reversal is key to comprehending mirror reflections. Mirrors reflect objects in a way that preserves the front-back orientation but reverses it. This reversal can create confusion when interpreting visual information, leading to the perception of left-right reversal. Number 10. Mirror writing and text reversal. Another intriguing aspect of mirror reflections is the phenomenon of mirror writing. When we write on a piece of paper and hold it up to a mirror, the text appears reversed. This effect occurs because the mirror reflection presents the back side of the text to us, which is not the usual way we view text. Number 11. Mirrors in different environments. Whether in a zero-gravity environment, on Earth, or anywhere else in the universe, the phenomenon of mirror reflection remains the same. Mirrors will continue to reverse the front-back orientation of objects, creating the illusion of left-right reversal, regardless of the specific conditions. Number 12. The influence of gravity. Gravity has no direct influence on the left-right reversal observed in mirrors. Even in a zero-gravity environment, the principles of reflection and the preservation of angles would still apply. Gravity does, however, affect our own orientation and spatial perception, which can indirectly influence how we interpret mirror reflections. Number 13. Mirror reversal and symmetry. Mirror reversal is closely related to the concept of symmetry. Objects that possess bilateral symmetry, meaning they can be divided into two equal halves, will appear unchanged in a mirror reflection. However, objects with rotational or radial symmetry may appear distorted or rearranged in the reflection. In conclusion, mirrors reverse the front-back orientation of objects, leading to the perception of left-right reversal. Our brain's interpretation of visual information, combined with our spatial orientation and the physics of mirror reflections, contributes to the intriguing phenomenon we observe in mirrors. The next time you gaze into a mirror, take a moment to appreciate the complexities of perception and the wonders of light. If you have found this video informative, so don't forget to hit that subscribe button and turn on notifications so you never miss a fascinating science update. Thanks for watching, and stay tuned for more amazing discoveries.